Hello, everyone. I'm Aaro, and I'm here today with our AI lead, Bernardo. How are you doing?
I'm very good, Aaro. And you?
I'm good as well. Let's maybe start on the model layer first. So, to me, it sort of feels like every week there's a new language model being hyped up as the best one ever. So, how does the community go about determining a new champion?
Yeah, that's a really good question. And as you said, like every week, it seems that there is like a new state-of-the-art model that is outperforming the previous ones. Um, so if we want to understand how models are compared, we need to talk about model evaluation and how the community and the ML engineers determine if a model is better than another one. So model evaluation tries to basically measure the overall performance of a model, or in this case of a large language model. And in order to do that, we need to evaluate these models across different tasks, subjects, domains, etc. So the researchers have basically created different data sets or benchmarks, and we use these for basically determining if a new model is better than others, or for comparing them as well. Just to give you an example, one of the most popular benchmarks is, for example, the MMLU dataset. That MMLU stands for Massive Multitask Language Understanding. And here, what you are trying to determine if it's the model, but basically how many tasks can this model do, for example. And then you're going to obtain a metric, like let's say like 80% on MMLU. Then there are more benchmarks, could be Truthful QA, ARC, etc. And then you're going to obtain like a metric for each of these data sets. And then you could say overall, this model, for example, overall GPT-4 is better than Llama 270V, for example. And the idea is to use these metrics to compare models, not systems. I think it's important to point that out, that you are actually comparing models, not comparing products or LLM-powered products or systems like assistants, for example.
What are the differences to evaluating LLM-powered systems instead of the underlying models? And why can't we just use a similar approach as you described with the models?
The main difference is that we need to be more use case or task specific, because your product or your LLM system is going to perform a very specific task. So in contrast with model evaluation, where basically we are trying to evaluate at a macro level, so basically the overall performance of that foundational model across different tasks, in LLM system evaluations, we are particularly interested in that specific task that the system should perform. If we are in the context of a RAG pipeline, for example, you want to measure if the answers that your system is giving are actually faithful to the retrieve context, or if the context has been hallucinated otherwise. If we are talking about a chatbot, then you want to measure or evaluate if the responses are actually helpful. And your users are going to dictate what helpfulness means for your particular product. Maybe it could be also the style of writing. Is this the style of writing that my users are demanding? So if you are someone building user-facing products that are powered by LLMs, especially in open-ended generation, then you are interested in system evals, in LLM system evals, because you need to evaluate like all the components that are in your system. Normally, if you are, and from our experience as well, it's important to pre-process the inputs that you are getting. So let's say that you are receiving a long inquiry, you might want to decompose that inquiry into different smaller questions. You want to evaluate that process as well. Then let's say that you retrieve some context using those inquiries, and then you have a prompt and an LLM synthesizing that response at the very end of your pipeline. Again, that's another evaluation that you want to perform. And those evaluations are much more use case or task specific. That's why LLM system evaluation is very different from model evaluation.
So when it comes to system evaluation, we already discussed the shortcomings of human evaluation in the last episode. So what kind of other, perhaps more scalable and less expensive techniques could be adopted to evaluate LLM systems?
Yeah, this is gonna sound like a bit weird if someone has never heard of this, but we could use LLMs to evaluate LLMs. So we use AI to evaluate AI. This is called LLM-as-a-judge or LLM evaluators, sometimes auto-evaluators as well. And actually, many of these benchmarks for evaluating models already uses LLMs. Like Alpaca Eval, for example, uses GPT-4 as a judge to select between different outputs. If you have Model A and Model B, you basically generate with the same prompt, and then you ask another LLM to say, okay, which output is better? So the concept is actually quite simple. Basically, you are trying to use an LLM to approximate human evaluation in a more scalable, sometimes explainable way as well. And in practice, what you do is you create a prompt template that basically asks an LLM to evaluate certain tasks. Typical example is, this is like a simplified template, but you could say, given the query and the referent text, is the answer actually factual or is hallucinated? Okay, the prompt is going to be much more sophisticated than this, but that's kind of the idea. I would say that one of the main advantages of using LLM as a judge is that they can be quite flexible and you can adapt them to the use case or your specific task. You could even provide like a few demonstrations of that evaluation and try to guide the LLM to evaluate in the same way that you are evaluating. I'll go back to the helpfulness example. To me, helpfulness might mean something slightly different than to you in practice. So you might use these demonstrations for actually align the LLM with your judgment.
So before we move on to talk about some of our own experiences with LLM judges, would be really curious to hear if the concept of LLM judges or auto-evaluators has been completely experimental by the community, or has there also been research supporting it?
Yeah, there is a lot of research supporting LLM as a judge or LLM evaluators. And I would say that one of the most influential papers was Judging LLM as a Judge, where basically they explore using a strong LLM like GPT-4 or nowadays Claude could be as well to evaluate other LLMs in the open-ended question context. The results were really good, and they reveal a really high agreement with humans, basically between GPT-4 and humans, and up to 80% agreement, if I remember correctly. And basically, they calculated this agreement on subsets of the empty bench dataset and the chatbot arena dataset that were actually created by human experts. So they evaluated on subsets of these datasets. The results reveal like really, really good, strong agreement.
Makes sense. So we've built quite a few LLM judges ourselves, and we've learned a lot while doing it. So do you have any advice for other AI teams who might face constraints with human evaluation and are looking to build their first LLM judges?
Yeah. First of all, I encourage everyone building with LLMs to at least try out LLM as a judge. It's not a perfect solution, but I think it can solve many problems. And combined with human evaluation as well, I think that's the best strategy for evaluation. I would say that, first of all, you need to think about the system prompt. It usually starts with something like, please act as an impartial judge, evaluate the quality, blah, blah, blah. And then you need to continue kind of explaining the task that should be evaluated. If you take a look at the research, there are many examples of these prompts that you could basically use as inspiration, perhaps combine them together. So I would recommend to start from there. Then when it comes to designing the evaluation task, you need to make a decision how you want to evaluate your inputs and outputs, basically. Usually, let's maybe talk in the context of a RAG system for question answering. You might use pairwise comparison. And this is basically for a question and a context, you're going to generate with two different systems, you are going to generate two possible answers, and then you're going to ask the judge, the LLM judge, to pick the best one. That could be an option. Then it's also possible to grade the outputs. You could ask the LLM directly to say, hey, please grade this answer based on this scoring scale that I'm providing. And then you could include different definitions for each score in the scoring scales. Or it's also possible to provide a reference of the output and then ask the judge, the LLM judge, to basically grade the output based on the provided reference. So that's possible. Both options are possible. It depends a little bit on the task as well. You could be a bit creative. But it's important to pay attention to the scoring scale, because if you go for high precision scales, like maybe from 0 to 100, the LLMs might not be able to understand like the subtle differences between like 35 and 50, for example. So I recommend either a binary scale, yes or no, and I would go for yes or no in the templates instead of 0 and 1, because that's going to be easier for the LLM, or a low precision scale if you need like a bit more granularity, like from 0 to 3 or from 1 to 5 is maximum. That's my recommendation. It's also being studied in some papers, and they also recommend like low precision scales. Apart from that, it's also quite helpful to prompt the LLM to provide an explanation of the evaluation as well, so you can interpret the evaluation and how the LLM as a judge is behaving. And this is seen in many of the approaches that you can find in papers. So you ask for an explanation of the evaluation and then a score. I 100% recommend this because it's going to help you understand how that LLM is actually evaluating your examples.
Those are some solid advice, but you mentioned that the method is still not perfect. So I'm interested to hear what kind of shortcomings do you have in mind for using an LLM to evaluate the performance of your LLM system?
Yeah. Well, I would say that as with every technique, there are pros and cons. Many of the shortcomings or limitations that I'm going to talk about come from experiments carried out by researchers. So I think we can trust this. LLM as a judge suffers from biases, different biases. One is the position bias. This is specifically for pairwise comparison. If basically you are providing two outputs, the first output tend to be selected by the LLM as a judge. And by the way, this has been also proven in human decision making. So it's not just something specific to LLMs. It also happens in human decision making. So there's this position bias that we should be aware of. There is also length bias, or sometimes also referred to as verbosity bias. This means that some LLMs has this tendency to prefer longer outputs, even if the outputs are of lower quality and less readable. Something to know about as well. And then there's another bias called self-enhancement bias. In simple terms, this means that GPT-4 tends to prefer GPT-4 outputs. So if you are using an LLM judge that utilizes GPT-4, and then you are presenting the judge with an output from GPT-4, there is like a higher chance that that judge is going to score that output higher. Something to know. So it's a good idea to use a different large language model for your judge compared to like the ones that you are using in your system. Another limitation in this case is that the smaller models might not have enough abilities to perform evaluations, and that's the case with 7B models. It's difficult to evaluate with them because they are not powerful enough. So we usually try to use the most powerful models for evaluations. And then finally, I would say that if you are using closed source models like GPT-4 or Claude behind an API, the problem is that these LLM providers, from time to time, they roll out new versions of that model, and you don't know when that happened, basically. And this could change the behavior of your judge, could change how the judge evaluates. And yeah, it's a problem for the LLM systems, but it's a problem for your evaluators as well.
Makes sense. So with human evaluation, you can typically consider it to be reliable, but at the same time, it's expensive and time consuming. And then when it comes to auto evaluation, it's very efficient, fast, and cheap, but you might suffer from things like bias and it's not as reliable. So that makes me think, how do you actually know that you can trust your auto evaluator or LLM judge?
Yeah. Before I jump onto that, I would like to point out that human evaluation is not perfect either. So it suffers from biases as well. So something to consider. But yeah, you are very right. How can we trust an LLM judge, basically? I think we need to meta-evaluate the judge. What I mean by meta-evaluate is assess the human alignment between the judge and your criteria. And there are some papers where they do that. The way to meta-evaluate your judge is basically, first of all, you start curating a small representative dataset that is going to contain inputs and also possible outputs. And then you are going to ask a human expert to basically evaluate or score those outputs in the same way and based on the same criteria that your judge is going to use, right? And then you could use that, let's call it like golden dataset. You could use it for calculating the correlation between the judge that you created and the human experts. And then you can keep that data set for like over time, like run some checks and make sure that, let's say that you're using a closed source model, that the new version of that closed source model, the performance of your judge hasn't degraded due to that new version, right? It's true that there's going to be a cost in creating that data set and also updating it if your data distribution changes, for example. But I would say that cost is affordable and much cheaper than human evaluation when you need to basically ask humans to evaluate if you make any simple change to your system or if something has changed in your data.
Awesome. I think that's a good place to wrap up the episode. Really, really valuable learnings here. But Bernardo, maybe you can give a bit of a brief on what might be coming up next.
Yeah. Next, I'd like to basically introduce a paper where they use a technique for inferring scoring criteria based on a golden data set that contains evaluation. So the idea here is to eliminate the manual step that you currently need in creating an LLM as a judge, because right now you need to craft a prompt template and it's a lot of trial and error and time consuming. So I like to introduce this paper to our audience. I think it's very exciting. I've gone through it in detail, so I'll be preparing an episode about that. Also, before we wrap it up, I'd like to say to our audience that if they have any feedback on these episodes, if they have some interesting topics in mind that they want us to discuss, feel free to reach out to us. Give like as many suggestions as you want.
Sounds perfect. Thanks a lot for tuning in and see you again next time.
Thanks, Aaro. See you soon.